Dear students, welcome to Impulse Masterclass. This program is designed for 10th class students. Myself, Gnana Krishna, senior faculty in physics. Currently, I am working in Impulse. Students, let's have a look at these two questions. This one is convex mirror, this one is concave mirror. Here, an object is placed at a distance of 60 centimeter from convex mirror, and here object is kept at a distance of 20 centimeter for concave mirror. Here 20 centimeter is the focal length of this convex mirror and 5 centimeter is the focal length of the concave mirror. Now find the image distance for both the mirrors. This is very important concept in a 10th class syllabus. Before going to solve this different type of models based on the spherical mirrors, first of all you have to concentrate on these four important concepts. One is spherical mirror, second one types of mirrors, third one focal length and radius of curvature, and last one mirror formula. Let us understand spherical mirror. Students, just imagine a glass spherical sphere, so which is hollow. So if you cut into two parts like this, one of the part will become like this, and if you cut like this, another part becomes like this. See, two different shapes you are getting here. From here you will get two types of mirrors by polishing. If outer surface, this one is called outer surface. If outer surface, if it is polished, that is called concave mirror. In case if inner surface of the curved surface is silver polished, that is called convex mirror. What is only silver polishing? So before going to know about the polishing, first of all you have to draw the axis. It is called principal axis, students. This one is called principal axis. This is called principal axis for both the mirrors. Now here for concave mirror, from here to here, if we assume that this is the center for this curved surface, from center to here, this one is called pole of the mirror. The distance from center to pole of the mirror is called radius of curvature r. For this convex mirror, if you extend the principal axis, this will be the center of curvature. Let us assume that. So from this pole of the mirror to center of curvature, this distance is called radius of curvature. Students, r means radius of curvature, which is the distance between the pole and center of the curvature for both concave mirror and convex mirror. So here silver polishing nothing but if light ray falling on that, there is no reflection, means no reflections takes place on side which is polished. Means if light ray, if it is falling like this, so here reflections does not takes place. If light ray falling on the surface, here reflections does not takes place. So nothing but reflections takes place only on inner surface of mirror, that is called concave mirror. If reflections takes place on outer surface of the curved surface, that is called convex mirror. This is the part of this portion I already told you. Nothing but this is center means this one only. So this is R. Okay, this is the pole of the concave mirror if polished like this. I hope you understood by now. Similarly, same position if you consider here, if it is inward polished like this, again this one is said to be radius of curvature. Same this one, which is equal to radius of curvature, and this portion, this portion. So this one both are having same center of curvature from the same glass sphere. Let us understand about the rays. Generally, rays are divided into two categories. One is marginal rays and another one is paraxial rays. See, let us consider a concave mirror. For this concave mirror, I already considered principal axis here. This one is incident ray. That incident ray is falling at the pole of the mirror P. Here, theta is the angle between the incident ray and the principal axis. The angle between the incident ray and the principal axis, if it is less than 10 degrees, those rays are said to be paraxial rays. If it is more than 10 degrees, those are called as marginal rays. In your 10th class syllabus, we are dealing only up to paraxial rays only. So in this discussion also, we are going to deal about only paraxial rays only. We already discussed about the spherical mirrors and types of mirrors. As you know that focal length of the rays is equal to r by 2 in 10th class, but those rays are called paraxial rays. About the marginal rays, you are going to learn in intermediate only. In spherical mirror concepts, these 3 points are very important. You need to remember. Let's go with the first one. Normal always passes through center. Let us consider a concave mirror. Any point on concave mirror, if you consider, and if you draw the normal from that point, for example, this is the point. From that point, if you draw the normal, it is passing through the center. I mean, at this point, if you make a tangent, here it is 90 degrees. Similarly, if you take another point at here, if you draw normal from that point on spherical mirror, if it is passing through center, this is called normal, students. Okay, if you draw tangent, here it makes 90 degrees only. So, any point if you take on spherical mirror, normal always passing through center. We already discussed in a plane mirror, that is angle of incidence is always equal to angle of reflection. Similar to as it is applicable in spherical mirror though. For example, let us consider a light ray which is parallel to the principal axis. It is incident at this particular point, let it be A. So where it is incident, that is called point of incidence. This point A is called point of incidence and this one is called incident ray. And this incident ray with the normal, how much angle it makes, that is called angle of incidence. So here, this is the normal, this is the incident ray, and this one is called reflected ray. Okay, this is called reflected ray. This reflected ray, how much angle it makes with the normal, that is called angle of reflection. These two angles are equal. That only here, second point I am giving here, angle of incidence equal to angle of reflection at the point of incidence with respect to normal. See here, this is called normal, students. Okay, with respect to normal, angle of incidence, angle of reflection, both are equal. Here, after reflection, where it intersects on principal axis, that point on principal axis is represented as F, which is called focus. So students, focus is nothing but a ray, I mean a paraxial ray, I already told you, which is parallel to principal axis. So a paraxial ray which is parallel to principal axis, when it is incident on the spherical mirror, whether it is concave or convex, after reflection it will passing through certain point on the principal axis. Where it intersects on the principal axis, that point is called focus. That point focus to pole, that distance is called focal length. So students, finally what I am concluding from this concept, focal length is nothing but the distance between the focus to the pole of the mirror. Remember students, not only here, if you take anywhere, I mean for example, if you take another parallel ray which is at certain amount of less when compared to the previous one, even though after reflection, I mean first of all you have to draw the normal which is always passing through normal. After reflection, it is always passing through this focus only. That remains always same. It doesn't matter about that rays, how much height it is coming. Students, I hope you enjoy the masterclass. See you in the next class. Thank you all.